This is the Honors Math 2 Unit 12 review. The first problem we start with is we have this graph f of x equals negative the quantity x squared minus 9. And we don't typically see the negative with the parentheses on the outside, so we're going to rewrite this as negative x squared plus 9. Which now looking at the graph, we see the negative does show that the graph does open down. And then the 9 shows a vertical shift for the vertex to be up and start at a coordinate of 0, 9. So for our first set, we're just going to answer true or false and just identify some different parts that we have within the graph. First off, we say that f of x is decreasing when x is greater than 0. So what we're going to do there is look at when x is greater than 0, the slope of that function, even though it's not a constant slope, is negative. So we'd say decreasing. That's true. The axis of symmetry is y equals 0. At first look, that does look correct because it is going through the y-axis, but it's actually x equals 0 whenever we talk about the axis of symmetry. The axis of symmetry is also the x value in the vertex, so that's false. The maximum value of f of x is 9. That is correct. That is the largest y value, so true. 2, 5 is a solution. What that means is the coordinate 2, 5 is a point on the parabola. If we go over 2 up 5, it does go through that point. Negative 1, 3. If we go to the point negative 1, 3, it does not go through that point, so that is false. 3, 0 is an x-intercept. That is correct. There's 3, 0. 0, 9 is an x-intercept. That is false. That is a y-intercept. The axis of symmetry is x equals 0. That sounds better. Better version of part B, so that's true. F of x opens down because of the subtraction sign before the 9. So the negative right here doesn't indicate the direction. It's the negative in front of the x squared or the coefficient on the x squared that causes it to open down. That's false. The vertex is 0, 9. That is true. The value of x when f of x reaches its maximum, so that is saying what is the x value at the vertex? That is 0, so that is true. The domain of f of x, our last part, is all real numbers. And then the range for f of x, it's going to be the y values. Now there's no y values above 9. It does include 9, but it's everything underneath it, so we'd say y is less than or equal to 9. For number 2, we're comparing our graph here of x and k of x. So if we look at the x-intercepts of k of x, that is when we have y values of 0. So right here and here, we have at negative 5 and 1, the function comes out to be 0. So the x-intercepts are negative 5 and 0. The y-intercept is whenever x is 0. So at this coordinate 0, 5, you have the y-intercept. Let's write that 0, 5. Go back to the other two. That was negative 5, 0, and 1, 0. The value of x when k of x is at its maximum. So for this, we really want to know the vertex. And if I look, I have negative 5 and 1, negative 4, 5, and 0, 5, then negative 3, 8, and negative 1, 8. The last, negative 2, 9, turns out to be the vertex. This is the largest y value. We could also think about that as being the maximum. So the value of x where that occurs is negative 2, which means the maximum value is 9 because the vertex is negative 2, 9. K of x is increasing when x is, so we know it has to do with the negative 2 because that is where it changes direction. So it's increasing, we went 9, 8, 5, that's going down. But if we go from the 9, 8, 5 in this direction, so it's moving from left to right, it's actually increasing. So we're going to say that x is less than or equal to negative 2. If that's the case, it's greater than or equal to negative 2 when it's increasing. For when k of x is increasing, we can look at the vertex, negative 2, 9. So negative 2, 9, we'll say it's about right here. We have these points, negative 5 and at 1, 0. And this is approximating. It looks similar to this. So from that negative 2 On the left side of it is when the function is increasing. So we're going to say that it's increasing when x is less than negative 2. We're then going to say that it's decreasing, so on this side, when x is greater than negative 2. For number 3, we have to match. So we have our 3 different forms: factored form, standard form, and vertex form, and which one shows different parts, which one makes it easier to find certain characteristics. Now, the maximum value has to do with the vertex, and so that's going to match the best with vertex form. So we're going to say that that matches with 1. So C matches with 1. Then if we're looking for the zeros or x-intercepts, the factored form would help you with that. So that would be 2. Factored form goes to the zeros. And then the third choice is we have standard form. Standard form really helps you to find the value of the function when x equals 0, also known as the y-intercept, and so that would be 3. Next problem, we need to find the vertex and sketch the graph. Now if we look, they're all very similar with slight changes. If we go through, our vertex is 5, 2 for the first one, 5, 2 for the second, and negative 5, negative 2 for the third. 5, 2 puts us about here for the vertex. With a negative value, we know it opens down. For part B, 5, 2 being the same vertex, but we have a positive a value, so it opens up. And you see the difference between the two. With the negative value in front, it opens down. Positive, it opens up. The last one has a vertex of negative 5, negative 2. But our a value is positive, so it would open up. For our next set, we need the axis of symmetry. As mentioned before, the axis of symmetry is the x value in the vertex. It's going to be the opposite of what we call the h value in vertex form. So we'd say x equals negative 1, x equals negative 5, and x equals negative 4. For number 6, we need, if the ordered pairs are solutions to the equation y equals negative 3x squared plus 1, we're going to substitute in for x and y and see if it's true. So we have 1 equals negative 3 times 0 squared plus 1. Negative 3 times 0 squared just becomes 0. So we're left with 1 equals 1. For part B, we have 37 equals negative 3 times 2 squared plus 1. That's 37 equals negative 37, negative 3 times 4 plus 1. This is going to come out to be negative 11, so that's false. For C, we have negative 11 equals negative 3 times 2 squared plus 1, which if we look, we just simplified this last problem, and it came out to be negative 11 on the right side with the same value, so that one works. For the last one, we're going to say 8 equals negative 3 times 1 squared plus 1. We have 8 equals negative 3 plus 1, 8 equals negative 2 is false. So the only ones that came out with true statements at the end were A and C, so those are our solutions. For number 7, we need to write off our information based off the graph. So we have our parabola here going through a vertex of 0, 5. The max or min value would be the y value, and this is a maximum, so we'd say 5. The axis of symmetry is when x equals 0, because that is the x value of the vertex. The graph is increasing on the left-hand side of the vertex, so that is when x is less than 0, and it's decreasing when x is greater than 0. For number 8, we have to describe the transformation from f of x to g of x. Now if we look at g of x, it has a vertex at negative 4, negative 2. So that's right here. Now it starts at 0, 0. So if we described the transformation, we went left and then down. So we went left 4 units and down 2 units. Everything else stayed. We did not change the steepness of the graph or the direction that it opened. So this is our transformation from one to the other. For the next one, number 9, same idea. Our vertex is at 3, 1. So we move to the right and then up. So we'd say 3 units right and 1 unit up. For number 10, we have 2 functions. We have f of x and we have g of x, and we need to start to compare information from it. If I look at g of x has a vertex at 0, 3. I'm just going to mark that. It's right here, and it is opening down. I don't really know how steep it is, but I'm going to use that 0, 3 to help me, and then I also have 3, negative 2 is the vertex for f of x. So which graph has a greater maximum value? So the maximum value is the y value at the vertex, and so in that case, g of x has a greater maximum value. The value of x when g of x is at its maximum is greater than the value of f of x at its maximum. So g of x at its maximum is 0. Is that greater than the 3 that we get from f of x? That is false, so we say no. Really, that question is asking which one is further to the right. So whenever it has its maximum value, the x value, whichever one's further right would be greater. The x-intercepts of g of x is going to be where the function goes through 0. And from here, we don't really have those coordinates. We would have to guess. It looks like it's going to be between -1 and -2 and 1 and 2. If we had more information, we could go through and solve, we could identify them, but for right now, that would be enough of an indication. For number 11, we need to state the zeros of our function. We could look at factoring this function if we said 0. So 0 equals x squared minus 5x minus 14. What multiplies to negative 14 that adds to negative 5? This would be negative 7 and positive 2. So that comes out to be x minus 7 and x plus 2. From here, we set each factor equal to 0 by the zero product property. So one solution comes out to be x equals 7. The other is x equals negative 2. For number 12, we have a ball thrown into the air based off of our function here, which we notice is in vertex form. We need to find the time it takes to reach the maximum height. So if I have an object going up in the air and coming back down, the maximum height is off its vertex. And in this case, it is 3:23. And to find the time that it takes, time is our x-axis, where height is the y-axis. So our time it takes to reach would be 3 seconds. Now if it asks for the maximum height, which it could easily change that equation, we would say it'd be 23. Now it also says for the above equation, what is the domain and what is the range? So what matters in the problem in order to solve it? So we have to look at the information that we're given. I know that it has the lowest height it's ever going to reach is 0 feet. So once it goes below the x-axis, it doesn't fit to the problem anymore. It also has a maximum height of 23. So the range for this one, we're going to say is between 0 and 23. For the time, the domain, it starts at 0 seconds, and then it goes to when it hits the ground. So we're going to say it's between 0 and that point that it hits the ground. So that's what we're going to have to solve for. So I have 0 equals negative 3 t minus 3 squared plus 23. We're going to subtract 23 from both sides. We're going to divide by 3, and now we have 23 over 3 equals t minus 3 quantity squared. We then take the square root, and we get plus or minus 23 over 3 equals t minus 3, and then finally 3 plus or minus the square root of 23 over 3 equals t. I don't really care about the negative answer here because the negative answer is on this side and I'm not worried about that in the problem. What I need to figure out is the positive result. So that's going to be 3 plus the square root of 23 over 3. The square root of 23 over 3 is about 2.8. So 3 plus 2.8 puts us at about 5.8 seconds as the domain of the problem. On to 13, we need to graph our equation. We have a vertex of -1, -2 from vertex form. That -2 tells us the first step. We can go down 2 units to help us set the width, and we'll get a sketch from there. So vertex is -1, -2. Our domain is all real numbers. Our range, since our y value is -2, actually put that in the wrong spot, should be right there. Hopefully you caught that faster than I did. So the range is going to be when y is less than or equal to -2. For our axis of symmetry, that's going to be the x value in the vertex, so we'd say x is equal to -1. The next problem is in standard form. So to find our vertex in standard form, we're going to go x equals -b over 2a. So that's -2 over 2 times 1. This comes out to be 2 over 2, or just 1. That is also our axis of symmetry. Now, we're going to substitute 1 into the equation. We get 1 squared minus 2 times 1 minus 15, or 1 minus 2 minus 15 gives us -16. So our vertex is 1, -16. To find the x-intercepts, which is also up here, we need to factor it down. So I'm going to go 0 equals x squared minus 2x minus 15. What multiplies to -15 that adds to -2? That would be x minus 5 and x plus 3. So we'd say x minus 5 equals 0, so x equals 5, and x plus 3 equals 0, so x is -3. So we have 5, -3, and then we know our vertex is at 1, -16, which would be off here, so we're just going to draw this part of it and show that if we wanted to, we could have our vertex down there. On a test question, you'd have the actual values on, it would fit on the graph, and you wouldn't have to worry about that, but it's good to make sure you have an idea of where it goes, and you could also use the x-intercepts to graph it. So those are 5, 0, and -3, 0. For our next one, we have x squared minus 4x minus 5. So x equals -b over 2a gives us -4 over 2 times 1, which is 2. That is our axis of symmetry. We now substitute that in. 2 squared minus 4 times 2 minus 5. We get 4 minus 8 minus 5. 4 minus 13 gives us -9. So our vertex is 2, -9, which would put us about right there. Our x-intercepts, we're going to look at factoring. We have 0 equals x squared minus 4x minus 5. What multiplies to -5 that adds to -4 would be x minus 5 and x plus 1. So x minus 5 equals 0, x plus 1 equals 0. We get x equals 5, and x equals -1. So we'd go to 5 and -1, noticing those are the same distance away from our axis of symmetry, that's 2, and that should hold up in our parabola. And then we sketch our graph. For number 16, a tennis player hits a ball while standing on a platform, and we have the path modeled here, where we have x is the distance the ball has traveled, and f of x is the height. And it looks close to this. So if the ball starts at x equals 0, based on the function, what is the height of the ball when it's first hit? So we're going to put in x equals 0, we have -0.02 times 0 minus 10 squared plus 21. -0.02 times 10 squared plus 21. So we're going to go 10 squared is 100. times 0.02 gives us 2, so negative 2 plus 21, so that is 19 feet. It was 19 feet right there. Now, based off the function, what is the height of the ball when it's 30 feet away? So now if it's 30 feet, we want to figure out the height. So we're going to go negative 0.02 times 30 minus 10 squared plus 21. With order of operations, we're going to go 20 squared right here. That's 400 times 0.02 gives us 8. So that's negative 8 plus 21. That comes out to be 13 feet as the height. For number 17, we need to find the zeros. So what I'm going to do here is, because it's two terms, it's a squared and a constant, I'm going to move the 32 to the other side, divide both sides by 2, and I get x squared equals 16. I then take the square root of both sides, and that's plus or minus the square root of 16, or plus or minus 4. For number 18, I'm going to find the zeros. Here I'm going to add 49 to the other side. Now I have the x squared by itself, so I'm going to take, or the squared by itself, I'm going to take the square root of both sides. So that's plus or minus the square root of 49. X minus 1 equals plus or minus 7. I'm going to add 1 over. We get 1 plus or minus 7, so that's 1 plus 7 is 8. 1 minus 7 would give us negative 6. And there's our two zeros. Number 19 is going to look very similar to 18, but we're going to follow a couple more steps in order to solve for the square root. We're going to first move the 50 to the other side to get negative 50. Dividing both sides by negative 2, we get positive 25 there. Square root of both sides gives us plus or minus the square root of 25, which is just plus or minus 5. Then we got negative 3 plus or minus 5. Negative 3 plus 5 is 2. Negative 3 minus 5 is negative 8. Those are our two solutions. For the next one here, I'm going to have to factor. So I have x squared minus 6x minus 40. What multiplies to negative 40 that adds to negative 6? So that's going to give us a negative 10 and a positive 4. If you're not sure about that, you could always use quadratic formula, which you'll see in a later problem. But in this case, since it's factorable, x minus 10 equals 0 gives us x equals 10, and x plus 4 equals 0 gives us x equals negative 4. And there's our two solutions. Next, we have to sketch the graph, x squared plus 8x minus 20. I'm going to look at factoring this first. Can I multiply to negative 20? That adds to 8. So if we went with what if we tried like 10, positive 10 and negative 2? So that multiplies to negative 20, that adds to 8, so there's our factors. Then we'd say x plus 10 equals 0 gives us x equals negative 10, and x minus 2 equals 0 gives us x equals 2. Now for this one, let's make each unit 2. So this means negative 10. So if we go to our solutions, we have negative 10 and 2. Now we know it does open up. We have y-intercept is at negative 20. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Let's say that's about here. Negative 20. If I want to find the middle of the two, so I have negative 10 and 2, the average of those two. So negative 10 plus 2 is negative 8, divided by 2 is negative 4. So there's my y-intercept. Not my y-intercept, my axis of symmetry, line of symmetry. That's x equals negative 4. Intercepts are negative 10 and 2. So now we need the vertex. So I'm going to take negative 4, substitute it in. We get negative 4 squared plus 8 times negative 4 minus 20. 16 minus 32 minus 20. That's 16 minus 52. So that would be negative 36 is our vertex. So it's -4, -36. Should be way down here. This is also one that's not very good to the scale. We'd want to go through those points. Down here, it's really going to be looking like it's down here is where it meets. I'm not too worried about the graph here. That's probably not the best values to have, but let's look at the important parts. X-intercepts, be able to find those, line of symmetry, and the vertex, and understanding how it does fit together. All right, for number 22, we have to again match the information about the equation with the equations that we have. So we start with reveals the maximum value of m of x. Let's also think of that as the vertex. So that would best go with vertex form. Something that reveals the zeros, or the x-intercepts of m of x, is going to be in factored form. So that would be b right here. And then last, reveals the value of m of x when x equals 0. That's the y-intercept, and that would go right here, be standard form. All right, now we can look at the equations that have no real solutions. So if they have no real solutions, they have imaginary solutions. So what that means is if we do square root of b squared minus 4ac, it gives us a negative number. So let's try that out and see what we get. So for this first one, we get negative 10 squared minus 4 times 1 times 8. And that's going to be 100 minus 32, which is going to be positive, so that one has real solutions. That doesn't count. Next one, we're going to go 12 squared minus 4 times 3 times negative 18. Well, I'm going to have 144 plus whatever this product is, 4 times 3 times 18, because it's two negatives, it's a positive, so that's going to have real solutions. I don't need to solve it out, it's just not going to be a negative. For C, we're going to do square root of 4 squared minus 4 times 1 times 21. Here I get the square root of 16 minus 84. 16 minus 84 is a negative. That's going to have no real solutions or imaginary solutions. For our next one, there is no b value here, so it's going to be 0 squared minus 4 times 1 times negative 36. That turns out to be a positive, so that one doesn't count. E, we have 0 squared minus 4 times 1 times 4, which is going to be the square root of negative 16, so that has no real solutions. And for F, we have the square root of negative 6 squared minus 4 times 1 times negative 7. It's going to be 36 plus 28. That's going to be a positive, so that will have real solutions. For number 24, what is the value in the C to make a perfect square trinomial? Or in other words, what would we use to complete the square? For completing the square, we're going to take half of the b value, half of 10, and square it. Half of 10 is 5, squared is 25. So that gives us x squared plus 10x plus 25, which would eventually become x plus 5 in completing the square. For b, it's the same idea. We're going to take half of negative 18 and square it, so that's 9 squared, or 81. So that would look like x squared minus 18x plus 81, which would eventually become x minus 9 squared. Next, we move on to imaginary numbers. So first off, I'm going to distribute on part A. I get 6i squared minus 12i. Now, I squared becomes negative 1. So this is going to be negative 6 minus 12i. And that's simplified down. We'll leave it as that. For part B, we're going to multiply these two values. I'm going to draw the box to help me multiply, but really I'm multiplying all the terms of the first parenthesis by all the terms in the second. So we get 6, negative 15i, negative 14i, and 35i squared. Writing that out, I have 6 is one term. Negative 14 and negative 15 is negative 29i, and then 35i squared. But I squared is negative 1, so this becomes negative 35. So negative 35 and 6, that's actually going to become negative 29 minus 29i. For part C, we have a division, so we have to multiply the top and bottom by the complex conjugate. So what happens is the denominator is going to become the first term squared minus the second term squared. So it's 4 minus 9i squared. Now we do that because it then becomes 4 plus 9, seeing that I squared is negative 1 and it makes it a positive 9. And eventually we get 13 as the denominator. So we do this process to get rid of the imaginary in the denominator. Now we have to go back and we have to multiply out on the numerator. Now that's multiplication like we just did in part B. So we're going to go 5 minus 2i, 2 minus 3i. We have 10 minus 4i, negative 15i, and 6i squared. So 10 minus 4i minus 15i plus 6i squared. 6i squared is going to become negative 6, so 10 and negative 6 is 4, and negative 19i. So we write as 4 minus 19i over 13, or in the complex form, it would be 4 over 13 minus 19 over 13i. Now we go back up to part D. We're going to distribute. We get 5i squared plus 20i, which is negative 5 plus 20i, seeing that I squared is negative 1. For part E, we're going to draw that box again. We have 2 minus I and 4 plus 9i. We get 8 minus 4i, 18i, and negative 9i squared. Writing that out, it's 8 plus 18i minus 4i minus 9i squared. Negative 9i squared becomes positive 9, so 8 and 9 is 17. 18i minus 4i is 14i. For the last one here, we're going to multiply by the complex conjugate, so that's going to be 4 plus 3i to the top and bottom. So the denominator, as before, is the first term squared minus the second term squared, 16 minus 9i squared, which is then going to be 16 plus 9, and then eventually 25. For the numerator, we're going to multiply, so 4 times 4 is 16, 4 times 3i is 12i, 3i times 4 is 12i, and 3i times 3i is 9i squared. 9i squared becomes negative 9. 16 minus 9 is 7. 12i and 12i is 24i. So 7 plus 24i, we then write in complex form 7 over 25 plus 24 over 25i. For number 26, we need to solve by completing the square. So we're going to act as if we can't factor this. And so we're going to convert it to vertex form as we go through, and that's kind of one use for it. But let's just think of solving. So I'm going to move the 5 over, and I get x squared minus 4x. I'm going to take half of the b value, negative 4, and square it. Half of negative 4 is negative 2. Squared is positive 4. And I'm going to add that to both sides. So I get 9 on the left side, which I'm not too worried about. I just have to make sure everything's accounted for. But the right side, I picked that 4 because this looks at what multiplies to 4 that adds to negative 4. Well, that's x minus 2 and x minus 2, or we get a squared. We have the two of the same thing. From here, we take the square root of both sides. I get plus or minus the square root of 9 equals x minus 2. And then 2 plus or minus the square root of 9, 2 plus or minus 3. Our answers are 2 plus 3 and 2 minus 3 for answers of 5 and negative 1. For part B, we're going to go x squared minus 16x equals 17. We take half of 16 and square it, so that's 64 to both sides, because half of negative 16 is negative 8. Left side becomes x minus 8 quantity squared equals 81. We're going to take the square root of both sides, and we get plus or minus the square root of 81, which is going to become 9. So then the 8 goes over, we get 8 plus or minus 9, so 8 plus 9 is 17, 8 minus 9 is negative 1, and we have our two solutions. For number 27a, we need to find the vertex of the parabola. Now this is in standard form. Our rule to find the line of symmetry is negative b over 2a. So that would be negative 6 over 2 times 1, or negative 3. We then take that and substitute it back into the function. So f of 3 is 3 squared plus 6 times 3 plus 11. 9 plus 18 plus 11. 9 plus 11 is 20, plus an additional 18 is 38. Our vertex is negative 3, 38. For our next problem, we're going to go x equals negative b over 2a, so that would be negative negative 2 over 2 times 1, or 2 over 2, which is 1. F of 1 is going to be 1 squared minus 2 times 1 minus 5, or 1 minus 2 minus 5, which is negative 6. And so our vertex is 1, negative 6. For 28, we need to determine the equivalent function of taking a standard form and writing it in vertex form. For this, we need to complete the square. So I'm going to write this one as f of x equals x squared minus 10x in parentheses, and then put a 1 on the outside. So this doesn't work for factoring, so we move the 1 out. I'm going to make this work for completing the square. So we talked about this a couple problems ago. We take half of negative 10 and square it, which is 25. But I'm not going to add it to this side of the equation. I'm going to stay on this side. So if I added 25 and then I subtracted 25 to the same side, I'm adding 0 to that side of the equation, but it allows me to complete the square. So now the parenthesis becomes x minus 5 squared, and then the extra terms on the end are minus 24. And that is how we convert to vertex form. We do the same thing again. We take f of x equals x squared minus 2x minus 5. We're going to go in parentheses x squared minus 2x, and then a minus 5. Half of negative 2 is negative 1. Squared is 1. We add that to the right side, so we subtract it to the right side, so it's equivalent. This factors to be x minus 1 quantity squared, minus 6 is our function in vertex form. For number 30, we need to graph and state the solutions of our function. So we have x squared minus 9. X squared minus 9, if we go right here to this point 0, 9, it is our parabola. So it's our vertex. It opens up. So it goes up 1. If I took 0 equals x squared minus 9, 9 equals x squared, so x is plus or minus 3. That tells us we have intercepts at plus or minus 3. Gives us a little bit more to sketch there. Okay, and then we have x minus 3. X minus 3 is just a line. It starts at a y-intercept of negative 3 and has a slope of 1. So we have there. Now, graphing is not always the best way to indicate the solution. So if we look, we have 3, 0, looks to be where they intersect, and negative 2, negative 5 seems to also be. But we can check this algebraically because what we're looking for is when they are equal. So I'm going to take x squared minus 9 and x minus 3. If I set those equal to each other, I'm going to move everything to the same side of the equation. X squared minus x. Negative 9 and negative 3 is going to, or negative 9 with the 3 added over is negative 6. We could do quadratic formula here, but I'm just going to factor. What multiplies to negative 6 that adds to negative 1 is x minus 3 and x plus 2. So it gives me solutions of 3 and negative 2, which if we look are the x values that we had. So now we go back, put them into either equation. We'll put it into g of x. So we know what 3 is one of them. So g of 3 is 3 minus 3, or 0. So one coordinate is 3, 0. And g of negative 2 is negative 2 minus 3, which is negative 5. So that would be the coordinate negative 2, negative 5 for our solutions. Next problem, we need to solve for x and leave in radical form. So this is going to be a quadratic formula type problem. We're going to go x equals negative b, so that's negative negative 4, plus or minus the square root of negative 4 squared minus 4 times a c, which is 1s and 1s, over 2a, which are 1. Clean up out front, we got 4, denominator is 2, plus or minus the square root, this is going to become 16, and we have a minus 4. From here, we're going to go 4 plus or minus the square root of 12 over 2. You cannot divide these two yet. You have to simplify that radical. So that's 4 plus or minus 2 root 3. Because 12 is 4 times 3, the 4 coming out becoming a 2. Then last, we can divide all three of these, or reduce all three of these. We get 2 plus or minus the square root of 3 is our answer. For the next one, we'll do quadratic formula again. We get x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 7, all of it over 2 times 1. This becomes negative 4 plus or minus the square root of 16 minus 28 over 2. And then we get negative 4 plus or minus the square root of negative 12 over 2. Negative 12 is, well, 12 we know is 2 root 3. We just did that type of problem. But now in this case, it's going to become 2i root 3. So negative 4 plus or minus 2i root 3 over 2. The negative comes out to make it imaginary. Now we can still reduce, or divide the 4 2's, the 4 and the 2's. So this is going to become negative 2 plus or minus I root 3 as our solution. For 32, we need to simplify our radicals when they're, we have some imaginary values working here. So negative 18. Imagine we're doing a quadratic formula and we get a radical with negative 18. We need to simplify that. First, I would recognize the fact that it is imaginary and just write I root 18. 18 is 2 times 9, so the 9 is going to give you a pair of 3's, and that's going to become 3i root 2. For number 50, we're going to make that I root 50. 50 is 25 times 2, which gives you a pair of 5's. So we're going to go 5i root 2 for simplified radical. Now we have I to the 45th, and then we also see I to the 53rd. For this one, we have to use the pattern that we have. Now, if we think of the complex plane, you have 1 and negative 1 are your real numbers. I and negative I are your imaginary. I to the first is in this location. Then we have squared to the third to the fourth, and it keeps rotating around because every 4 it repeats. So instead of counting this around to 45 or negative 53, we just want to think of what it's equivalent to. Because it repeats every 4, we could divide or think of a multiple of 4 that's right before 45 and find the remainder. So for example, I know that I to the 45th is I to the 44th and I to the 1st. Since 44 is a multiple of 4, it's the same as I to the 4th, so it just comes out to be 1 times I, which just gives us an answer of I. For I to the 53rd, now we're going to have that negative there, so let's think of this. That negative is negative 1 times I to the 53rd. I to the 53rd is I to the 52nd times I to the 1st. And I picked 52nd because 52 is divisible by 4. You could always just divide the number by 4 and then figure out what's left if you're not sure about the multiples. But since I to the 52nd is a multiple of 4, that just becomes 1. And then you got I, so we put this all together, we get negative I as our answer. For number 33, we need to solve with a quadratic formula. So we're going to go x equals negative negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times negative 1. All of that over 2 times 3. We get 5 plus or minus the square root of 25 plus 12 over 6. Now we have 5 plus or minus the square root of 37 over 6. 37 does not simplify as a radical. We're just going to leave it in this format. For our last problem, we have a rectangular court. The walkway around the perimeter is constant on all sides. Okay? So that's our x value there. The court and the walkway have a combined area of 130 square meters, so the total area is what we have here. So let's kind of set up what we have. So if this is 7 and we have x's on either side, this is 7 plus 2 x's. Then this dimension is 10 plus 2 x's. Now, if we're going to solve and think about the area, we know that 7 plus 2x times 10 plus 2x equals 130. Because the base times the height, or the length times the width, is equal to the area. Now from here, we can multiply this out. So multiplying all the terms in the first by all the terms in the second, I get 70 plus 14x plus 20x plus 4x squared equals 130. Rearranging this, I get 4x squared plus 34x plus 70 equals 130. That's 4x squared plus 34x minus 60 equals 0. Now this is turned into a quadratic where we're going to solve. So we first look through, can I divide all of these by a value to make them smaller? I could divide them all by 2. So let's make this 2x squared plus 17x minus 30 equals 0. It's not necessary. It does give us smaller values to work with though. So now we're going to quadratic formula. So now that we're going to go to quadratic formula, let's pause real quick, make sure we know that the equation that we're solving for was the one we set up for the area. So quadratic formula is going to be negative 17 plus or minus 17 squared minus 4 times 2 times negative 30, all of it over 2 times 2. We're going to act like we don't see that writing there. So what we get now is negative 17 plus or minus the square root of 289 plus 240 over 4. This becomes negative 17 plus or minus the square root of 39 there. 5, let's get it again, 17 squared plus 240, we get 529 over 4. This becomes negative 17 plus or minus 23 over 4. So our answers are negative 17 plus 23 over 4, or negative 17 minus 23 over 4. Well, this is going to give me a negative solution. I don't really want that. What I get here is 6 over 4, which is 3 over 2. And that's the answer we want. So it's 3/2, or 1.5 meters. As we look up here, and I had to scratch out because I had to record again, forgot a negative. 1.5, if we put 1.5 here and here, that gives us a total dimension of 10 instead of 7. And then 1.5 here and here gives us a total dimension of 13. 10 times 13 is the area we wanted originally, so the width is 1.5 meters as our answer.